because if you fall within the indeterminate space, so the chances of falling within the indeterminate space is less. But here the chances are more.
डिसीजन स्पेस कम हो जाएगा.
Decision space कम होगा. And you also need, it's not only about the cells, but also about sense amplified, you are sensing the data. Not only about. Okay. So we will study all these type of memories, like this is like an overview of different type of memories that you need to know. And another type of memory is called as rest rate memory. Rest rate memory. And rest rate memory stores the data in the form of magnetic domains. So this is a fixed domain. This is a fixed domain. This is a fixed domain. And this is the okay. So now if you look at this magnetic domains, so this stores the data in the form of magnetic domains, which we have a fixed layer, okay, and then we have an access port. If you look at this domain D0, D1, D2, D3, D4, D5, D6, D7, how many data it's storing?
3 bit.
8 bits.
Oh, sorry.
8 bits. Okay. So if you want to access D7, what we need to do?
111.
We need to move D7 with respect to the access port. We need to move D7 with the access port. And to move D7 to the access port, we need to apply some shift current. What we are doing? Shift current. When we apply some shift current, so okay, which port is aligned with the access port?
D4.
D4 is aligned. If we want to access D7, what we need? We apply shift current in this direction or in this direction? From the right or from the left?
From the right.
From the right. When we apply current, so actually it will move the domain, and actually the state will be D7, D6, D5, D4, D3, D20. How many shifts are required? 3. 1, 2, and 3. So in rest rate memory, it stores the data in the form of magnetic domains. The magnetic domains can either be in parallel to the fixed domain or anti-parallel to the fixed domain. So this one is parallel to the fixed domain or anti-parallel? Parallel. Parallel. Anti-parallel. Anti-parallel. Parallel. Anti-parallel. Anti. One logical state may be used to represent a logical 1. Okay, and another can be used to store up to represent a logical.
ये शिफ्ट की समझ नहीं आएगी. हम शिफ्ट देंगे तो बाकी ये D0, D1, D2 लॉस नहीं होंगे.
कौन से D0? Then it will move. Why it will be lost?
ये सर्कुलर शिफ्ट है कि क्या है?
It's not circular shift. It's magnetic strip.
मूवमेंट है ये.
Movement है. When it's D7, and now actually when it's D7 is aligned here, so it will be D7, D6, D5, D4, D3, D2, D1, and D0. If we want to align this with this port, how many shifts then we need?
6.
1, 2, 3, 4, 5, 6, 7. So if it's just like an elevator. In an elevator, you have, let's assume, one port, From here you can read the data. Okay, and then you can shift from here to here, and you can shift from here to here. So rest memory is a very high dense memory. It can store multiple. And actually, what is this is a rest memory cell. This is called as a stack. It is called as a track.
Rest.
It's a track. This track consists of how many domains? 8 domains. And it can store how many data bits per track? 8 bits per track. Okay. To read a particular data item, we need to shift the desired domain with respect to the access port. And what is the worst case shift penalty? Worst case penalty?
7.
D minus 1. What is D? D refers to the number of domains that can be stored in a track. What is the best case penalty?
बिल्कुल पैरेलल में हो, आमने सामने हो, 0.
So the best case latency is 0 and the worst case is
D minus 1.
let's assume you're on 3rd floor. Okay, and you press the button to the left and the lift is open. It means it's already aligned.
Yes, sir.
When the current location is 3 and actually you just press the button and the current location of the lift is 9, then how many steps will be required? 6 steps will be required. So it's simple. So it's a serial memory. It's a serial memory. In which the data is accessed serially from within that track. Okay. So now, if you want to access multi-bit data, how can we organize the data in rest memory? We store multiple bits. Can we do it like this?
Yes, sir.
The size of the data is 64 bits. How many tracks do we need? 64 parallel tracks?
Yes.
Okay, so this is bit 63, bit 62, bit 61 up to bit
0.
00. And this is actually location 0, then location 1, and in the last location what? D minus 1. And what is D?
Number of states.
The number of domains.
Domains.
The number of domains that can be stored in a track. It's a track. In the previous example, it's a track. Track. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. How many domains can store? 8 domains per track. Now in this case, how many domains it is storing?
D minus 1.
D.
D 0 से start होगा.
So it's actually we have how many domains per track? D domains per track. Now we have an access port position. Let's assume that the access port is currently pointing to location I. The access port is pointing to location I. And if we want to access desired location is location J. So what is the shift distance, shift cost? What is the shift cost?
J minus I.
I minus J absolute.
Absolute.
Let's assume if your current location is 5 and the desired location is 7. So 5 minus 7 is
2.
minus 2. So it should come absolute. Okay. Okay. Now this is the organization of a rest track. Organization of the data. And how? Then Now, we already have published a paper that how we can efficiently organize the data in a restrict memory. And I will also explain this paper with you in very simple.
सर हमारा एक और क्लास भी है इसके बाद सर
7:30 की नहीं
तो 10 मिनट में उधर तक जाना भी है सर मेन
जाना है 7:30 तक क्लास है मैं तो 7:30 तक क्लास में था
7:20 तक है सर
चलो मैं 5 मिनट्स में और दे देता हूँ मैं जल्दी बता देता हूँ
ठीक
ठीक है ओके नाउ लेट्स assume you are multiplying a multiplied by b is equal to c it's a matrix multiplication so this is a okay if you look at this matrix a 0 0 a 0 1 a 1 0 0 2 a 0 3 a 1 0 a 1 1 a 1 2 a 1 3 a 2 0 a 2 1 a 2 2 a 2 3 a 3 1 a 3 2 a 3 3 a 3 0 3 1 0 1 2 3 3 3 2 and a 3 2 cross b b 0 0 b 0 1 and so forth same what is the result matrix C00 yes. So if you want to compute C00 what we need to do first row first column okay now what we did in our paper that if you want to compute this with this so now let's assume that if you are storing this in restrict memory so if you store this restrict memory in this fashion so first you access this in restrict 0 and then you access this in restrict 1 so when you access your port is aligned with A00 so in that case the port will be aligned with
B00
next time you make a single shift then you multiply A01 with
B10 yes sir
B10 sorry then A02 with
B20
this was the optimization that we did in one of our paper we know the properties of the restrict memory so if you are performing okay now in the next iteration we stored this A3 in reverse order because when you reaches here so you need a long jump from here to here so instead of doing this we store this in reverse order and from reverse order and we also store this in reverse order in this case the port position reaches here so if you want to make the next computation so we need a long jump from here to here from 3 to 1 to avoid this long jump what we did we actually stored this in reverse order so what we did that actually this is the layout of the matrix okay now what are the different storage options what are different options that it is how does we organize the data so if we organize the data like in this row measure order and this row measure order so it will incur a large amount of shift we call it as a naive approach and in our approach what we did we stored matrix A in this order the first row and the next row in the reverse order so for this do we need a shift no we don't need if you store this in this order like this so actually what you are doing you are coming from here to here then you make a long jump then again long jump to avoid this long jump how we did we store the data in A00 A01 A02 A03 and in the next iteration we store the data in this direction A13 in the reverse order. So in this way we reduce the number of shift operations. This is called as the layout in memory and now this is a very simple like in this example we assumed how How many data items you are storing in a track? 4. Let's assume if the matrix is 64 by 64 and the length of this domain, the length of the track is, let's assume, 64. So what's the worst case shift now?
64.
63.
63. Yes, sir.
So we are avoiding many long jumps. And how these long jumps are avoided? By intelligently storing the data in memory. By intelligently storing it, this is called as layout optimization. How do you store the data in memory? It also has an impact on the performance of the memory. So we will study these kind of optimization. We will study this optimization in more and more detail, but I just wanted to give you an overview. We will study different types of memory technologies. We will study different characteristics of different memory technologies, and then we will see that what kind of optimizations can we achieve while considering the properties of the memory technology and also the properties of the application characteristics. Okay, and